First topic is vector calculus. As I told you, vector calculus is a huge topic, but I'm going to cover the concepts. Those are those are applied in your electrostatics, right? So to understand, vector calculus, this differential calculus, here we are dealing about differential calculus. To understand this differential calculus, you need to know what are rectangular coordinates, cylindrical coordinates, spherical coordinates, and what is this coordinate system, first of all, what to do with this, and what is the scalar, what is this vector. If you know these terms, then you can go straight away with the Dell operator. In order to understand Dell operator, this is the concept that is applied in your electrostatics. That's why I have chosen this. I didn't go in deep about vector calculus, right? So now, coming to the Dell operator. To understand Dell operator, what you should know, you should know the coordinate system. You should know what is coordinate system, and then you should know the scalar quantity, vector quantity. If you know that, then we can move on to the Dell operator. So what is coordinate system, guys? You must have learned about it. Yes, that's not difficult. That is very much simple. Here I'm going to show you what is coordinate system. So coordinate system is used to represent, okay, represent an object, okay, in three-dimensional. Okay, the very necessity of coordinate system is representing an object or a particle in three-dimensional system. So the dimensions used, so you might use the dimensions as x, y, z, x or y or z, all these x, y, z, or in terms of the in terms of the distance. Okay, it is only in terms of distance. If you use only the distance units in your x, y, and z axis, then it is called rectangular coordinates. In your cylindrical coordinates, you are going to use something called psi. The angle is going to be also used. If you use angle instead of z, here if you are going to take angle axis, okay, then you will end up with cylindrical coordinates. If you are going to use another angle, if you are going to use theta and psi, here if you are going to use another angle called psi, instead of going with the x, y, z axis, if you are changing your basic coordinates as an angle, two distances, or if you are going with one distance and two angles, then the coordinate system that you are using will change. The purpose of using coordinate system is just representing whatever the particle or object in what, in graphical form. So in a graphical or in a pictorial representation, you need to bring out what's happening physically, what is happening, you need to bring out it. So this is like a circuit, right? Why do you go for circuit? I have told you in my previous class, the circuit purpose of the circuit is to bring out the mathematical analysis of various elements when they are connected, right? So similarly, when there is something happening in miniature form, in charge form, or is very smallest particle, when you are analyzing that smallest particle, you need to represent how it is moving, where it is placed, what it is going, what it is experiencing. To bring out that physical phenomenon on paper in terms of equations, you need to represent it somewhere in the space. So when you are going to represent it in terms of distance, then it is rectangular. When you use some angle, then it is cylindrical. When you use two angles and one distance, then it is spherical form. Clear? So for now, you know what's the coordinate system. Now come on to the Dell operator. What is this Dell operator? Yes, Dell operator, what we do is, mm, since we are representing a particle or object in three-dimensional, and when you move or when there is a displacement, when there is movement or displacement in the particle, so that displacement you need to represent it in paper, right? That displacement has to be represented in all the three dimensions. See, when a particle is moving from A to B in the direction of x, okay, you can say this is the distance d in the direction of x. But when you have three coordinates, then you need to show the displacement in three coordinates, right? So at that time, you need to use this operator called del. That is the del operator to show your displacement in coordinate system, right? So in terms of x, it is dou by dou x, ax. What is this ax, ay, az? Yes, that is used to show your direction. So I told you A is moved to B in the direction of X. So this displacement is shown in directions of X, Y, Z using the unit vectors. So that unit vectors, if you add it, if you multiply it together and show, then it shows this dou by dou X displacement in the direction of x, in the direction of y, in the direction of z, because the magnitude of this is 1, right? That is the basic of vector calculus. Of magnitude of unit vector is 1, but it is showing the direction. So that's the purpose. In all these equations, you are showing the displacement in those coordinates using a unit vector, right? So that's the explanation for Dell operator. Now, when you apply the Dell operator to a scalar quantity, what is scalar quantity? What is vector quantity? Yes, those are all also very, I mean, whatever you have studied in your physics of your schooling. It's the same thing. Scalar is nothing but the quantity or I mean, an element without direction, which is having only magnitude. So when you apply this gradient to the scalar, then it is called, then it is shown as this. So when you apply uh, the grade, I mean, this del operator to a vector, then you call it as what? Divergence. So I have shown this, I mean, portion of this picture because, see, you should know some of the terms used in the vector calculus. When you are familiar with the terms used in this vector calculus, then you can easily correlate with these concepts when you in electrostatics, right? So when you apply your del operator to your scalar, you call it as what? You call it as gradient. When you apply it to a vector quantity, you call it as divergence. When there is a cross product, you are applying the del operator, but you are not applying the dot product. There is some difference between dot product and cross product. This is also basics of vector calculus. I assume you're familiar with all the vector calculus concepts because that is from your school's physics subject, I guess. In your secondary schooling, you must have studied. So this when you apply the dot product of del operator and a vector, then it is called divergence. When you apply cross product of the del operator and the vector, then it is called the curl. Okay, there is an angular difference you must have studied. When you write del a cos theta, then it is dot product. Del a sin theta, it is called the curl. Okay, cross product and dot product. Okay, that's the basics of del operator.